Thank you, Sean. Welcome, everybody. That's me. I'm a Business Development Manager for Stabilised Pavements. We're a specialist in situ recycling contractor. We work all over the country. We deliver about 300,000 square metres of in situ recycled maintenance programs a year. I just want to talk about not so much the process, but just a few developments within our treatment that are there for a number of reasons, both commercial and environmental, and to help our clients in their journey to achieving what they need to achieve on maintenance of their infrastructure. So the process is, for those of you who don't know, it's big machines chewing up the existing materials in a road asset. It's cold, so it doesn't matter if there's tar present in the road. We use a cementitious or a bituminous binder then to hold that material together. It can be as low as 2%. Our stand's got a number of cores of various different types of binder that have been used, so you can see for yourself the end result that's been put together, as well as the carbon impact of each one of the designs. There's a little demonstration here on this slide. This is a kilometre of road that's 7 metres wide. Would typically, to remove that material and replace it, would be around 330 lorry movements. For us, because everything is re-engineered underneath the machine, stays on site, is about 17. So it's mobilising to site, it's getting the job done, and reducing any impact disruption-wise or carbon-wise on the surrounding network. Generally faster build times. We're anything between sort of 1,000 and 4,000 square metres in a shift can be recycled. Once our recycling is done, we would then put a surface course or surface dressing, depending on the design, straight down and can be trafficked straight away. All of these things are targeted really to reduce the time on site, thereby reducing cost and carbon. This is a carbon breakdown that you can find in the RSTA carbon calculator. The top bar chart there is a traditional recon option of a 60mm binder, 40mm surface course on top of 100mm of base, weighing in at a little under 25 kilograms of carbon equivalent per metre squared. For us, recycling 170mm and overlaying with a 40mm asphalt would be a little under 12 kilograms of carbon per square metre. So massively reducing carbon in the maintenance. For us, improvements are either around materials, fuel equipment, or pavement life. The longer the pavement life, the less intervention, the less carbon. Our in-house R&D have been busy for us on the stand. They've got a number of, as I say, cylinders there that you can have a look at the carbon, feel the cylinders, look at the sort of materials we're producing underneath these machines. From testing, from using materials from the roads that we're about to recycle, we can hone in the design best suited for that particular road. One thing you'll see over there is the product, a calcined clay product, which is an alternative to a regular cement. Although Cemex have been working on their carbon, we know that cements are high embodied carbon product. They're looking to reduce their carbon from currently around 600 to 400 kilograms of carbon per tonne. So they're making improvements on their product. For us, there are alternatives. This trial we took place in Norfolk. H-Eva Sol is a particular product, calcined clay, as I said, about 60% reduction in carbon further from the traditional cementitious binders. So again, it's new. The trial's been successful. There's plenty of other authorities here. Talk to us about getting this into the network. The more we can use this stuff, the more likely the cost is going to come down because of local distribution. It's currently being produced and imported from Dunkirk. Not too far away, but it will be better with the distribution in this country. These are the numbers which I can run through with you on the stand. Just we don't chase a Newton strength. For us, it's all about surface modulus and that stiffness to carry loads. But in comparison terms, HE the Sol has been looking favourable to our more traditional binders. On to plant equipment, we HVO has mixed views really. For us, we work with Milestone. Milestone have a number of depots now with HVO which make available to their supply chain. Our machines can all use HVO fuels without losing warranty. Wirken are happy for it to use it. If it's reducing carbon on site, then it's beneficial to everybody really. With larger machines, this is a latest Wirken technology, operates at 3.5 meters wide as opposed to 2, thereby almost doubling the output. Again, it's about finding the appropriate road for the appropriate machine. But this particular machine, the 380 CRI, is a bit of a game changer and is up at 4,500 square meters in a shift, recycled and placed back in the road, ready to receive surface oil. This Pavement machine is fairly novel in that the drum can shift sideways. So if we're working on a narrow road where turning round's restricted, we can literally get to the end of the road, shift the drum over and operate in the other direction. It just saves a little bit of time. We're all about marginal gains to bring costs down and bring the outputs up. This is outside the one of these tandem Pavement steered tandem rollers. We do a lot of work in the fens with very deep drains either side of the road. There's certain safety issues around rollers, particularly on the edge of the road. With this, we can keep a driver near the centre of the road, thereby reducing any risk of actually leaving the carriageway. Hybrid technology, as it is most of the BOM these days. Back into sort of extending the life of the pavement here, in situ foam. A lot of authorities, as a result of flexibility, I think a foam mix is appropriate in certain environments. We can generate the foam mix under the machine. We recently did this for Oxfordshire on a rural lane at Berwick's alone. It was a 300 ml foam treatment that effectively took care of a failing foundation, a failing binder, and then that was surface dressed, and it's holding up very well. So it's an option that's out there. Again, some figures and some real life practicality that are on the site for you to look at. This is the Oxfordshire job, saving 564 lorry movements, 8 days quicker than the alternatives they were looking at, and a 227 tonne carbon saving. In addition to foam, there are other mitigations around poor foundations. In this case, we can demonstrate a geotextile and a geogrid below our recycling material, saying behind our machine we can unfurl this geotextile and geogrid, place the recycled material on top of it so it sits deep in the road, hereby providing more stable foundations. Other products like RoadSem by a company called PowerSem are an additive we use very successfully where core drainage, shallow clays, generally core conditions, challenging conditions. This enables us to use a little bit more cement without fear of cracking. As a result, it's been very helpful to us in certain environments which would otherwise have been not necessarily ideal for us to recycle. RoadSem effectively changes the way the cement behaves. Again, come and have a chat with us about more detail, but it increases the flexibility just by altering the way the cement hydrates. And it keeps a stiffer, shallower surface. The traffic is less likely to impact the clay layers below, again, making them a more robust surface for the road. We've done some graphene trials. Whether or not it'll ever be a massive rollout, it's very, very expensive. But on the A1, in amongst our blended cement, graphene was installed. It's ongoing monitoring. National Highways are looking at it. BTS are looking at it. Time will tell, see how it's performed really. The challenge for us was actually mixing such a small amount of graphene in with such a large amount of blended cement, which we did successfully through Semblend. Mixing on the site, it's actually the same way as we would normally. It's just in there with the powder. Obviously, we've taken our own sample analysis as well as BTS, and we're keeping an eye on it. Finally, just a couple of things we're looking at. So we've always talked about reuse of treated wastewater. It's effectively enables our Bowsers to fill up with water treatment plants. There's no reason for using potable water in construction, in my opinion, and we're hoping to make more use of this as it just makes sense. Lignin, finally, is used occasionally as a bitumen replacement. It's a byproduct to water and paper, so it's basically a wood in the manufacture of paper, and so when in its sticky form can be used as bitumen replacement. You can dry it out as a powder, can be added to our powdered binders, which will reduce the cement quantity. It's currently used in soil stabilisation, and so we don't believe there's any reason why we shouldn't at least be trialling this stuff on carriageways. In terms of how we try and deliver our message, it's events like this, so that we can really hopefully furnish you with a bit more information than 20 minutes allows up here. Come and see us at the stand and enjoy the festival. Thank you for listening.